Good afternoon, my name is Eduardo Santana and today I will present my final report for Evidence 2. This presentation summarizes my experience in the Marlock simulator where I applied logistic concepts such as transportation planning, inventory management, warehousing system, and demand forecasting. Through this simulation, I was able to understand how operational decisions directly impact supply chain performance and profitability. The main objective of this report was to analyze the 10 decisions made throughout the simulator and understand how logistics variables interact with each other. The most important variables I managed were inventory levels, transportation costs, forecasting accuracy, warehousing, and profitability. One of the most important lessons from this experience was understanding the supply chain decisions are interconnected. A change in one area immediately affects the others. At the beginning of the simulator, my main priority was ensuring product availability, so I maintained high inventory levels. Inventory reached approximately 97,000 kilograms, and weekly shipment averaged between 15,000 and 55,000. This strategy successfully avoided shortage, but it created excessive storage costs and eroded cash flow efficiency. The main lesson here was that having too much inventory can be expensive and inefficient, because the limit was 80,000 and we were up to 97,000, which caused that in next decisions we will need to reduce our packages to avoid this excess of inventory. After identifying the overstocking problem, I made a strong connection by reducing orders to only 50,000 kilograms per week. That was the bare minimum. This helped me reduce storage costs and improve inventory control. However, it's also increased the risk of stockouts because the inventory buffer became much smaller. This phase taught me that the inventory reduction improves efficiency, but only if it's aligned correctly with the demand. One of the biggest challenges in the simulation happened when a maritime shipment of 5,000 units did not arrive. Was when I was correcting the inventory overexcess and I was charging the bare minimum, and this was difficult. This caused inventory levels to drop significantly and create strong pressure on the supply chain. Demand stayed close to 50,000 kilograms, so I had to react quickly and use emergency transportation options such as airplane. This situation showed me that the transportation delays can create major inventory problems. During weeks 25 to 28, I shifted my focus from profitability to operational recovery. My shipments during the phase reached between 35,000 and 42,000 kilograms, and I relied more on trucks and maritime transportation because they were cheaper. The goal was to rebuild inventory and stabilize operations. Even though profits were not the priority here, the phase was critical to regain control of the situation. During weeks 29 to 32, the recovery strategy started showing results. Inventory became much more stable, ending above 69,000 kilograms, and available inventory exceeded over 81,000 kilograms. At the same time, freight costs became lower because emergency shipments were not longer needed. Weekly profits remained positive and reached almost $70,000 as a profit. That is very good comparing it to last decisions. This phase showed that the stability is essential before maximizing our profits. Once the operation became stable, I shifted my strategy toward profitability. During this phase, profits increased from around $3,000 to approximately $500,000. Finally, inventory levels dropped around 18,000 kilograms, showing much healthier inventory management. This confirmed that profitability improves when transportation and inventory are balanced efficiently. Through the simulator, I used different transportation methods such as air freight, trucks, freight forwarders, rail, and maritime transport. At the beginning, I relied more on air freight because it was faster, but it was also expensive. Later, I transitioned to trucks and maritime shipments, which reduced transportation costs significantly. The main lesson here was that the transportation decisions must balance urgency, cost, and efficiency. Packaging is essential to protect the product, optimize storage space, and improve palletization. I also consider important international pictograms such as fragile, keep, dry, the setup, and handle with care. For inventory management, the best model for this operation will be the economic order quality model combined with safety stock. This combination helps minimize costs while reducing shortage risk. Different transportation modes require different documents. For maritime shipments, the bill of lading is essential. For air transport, the airway will be required. Road transportation requires the Carta port, and rail uses the rail consignment note. I also considered important Mexican regulations that could be are that such as NOM 12, NOM 87, and NOM 68. For forecasting, I used MAPE to measure forecast accuracy and concluded the exponential smoothing was the most effective method. To conclude, the Markov simulation was one of the most valuable practical experiences of this course. It helped me understand that logistics requires balance, too much inventory, increased costs, while too little inventory increased shortage. It also reinforced that transportation, inventory, forecasting, and warehousing are all connected. The most important lesson I learned is that operational stability must come before profitability. Overall, this experience strengthened my analytical skills and improved my understanding of real supply chain decision making.